Okay, we're gonna see if we can try and finish this last example. So again, we were talking about that we have um, these different properties that allow us to like switch bounds as needed, break apart intervals as needed. Um, so let's look at an example of that. So this says let f and g be continuous functions such that I have this first integral from 0 to 6 is 9, from 3 to 6 is 5, and from 3 to 0 of g of x is -7. And they ask me this long thing. So first off, notice that we can kind of treat these as two separate intervals, okay? Because I can just separate this out into subtraction. Next up, we are allowed to like kind of just forget about our 1/2 and our 3 for a little bit. And then I really just have to figure out, okay, what is the integral from 0 to 3 of f? So coming back up here, these are the integrals that I had that dealt with f. So notice that my first one gives me the entire integral from 0 to 6. The second one only gives me the second half, which is 3 to 6. So if I know what the second half is, if that's 5, then I know that basically I cut this in half at 3. I know that the first part of this had to be 4. So we know that we have 4 is my f of x. I still have that 1/2 out in front. And then I have minus, and then we have 3. And then, again, I can just really look at this g of x from 0 to 3. Well, I know that the integral from 3 to 0 of g of x is -7. We don't want from 3 to 0. Also, 3 is bigger than 0, so it doesn't really make sense for our bottom bound to be 3. So if I want to switch these, okay, I can do that as long as I make this positive. So that becomes a +7. So we end up with 2 minus 21. So we get a -19 as our answer. Lastly, we have, so again, I'm going from 4 to -10. We don't really like those bounds. We're going to flip them. We're allowed to do that as long as I make or change this to the opposite sign. And then I also have from 4 to 6 is 5. So we know that from -10 to 4 is 3. So that gets us like part of the way. And then we know that from 4 to 6 is 5. So we can take that first part, which is 3, add that second part, which is 5. So we get a total of 8. And that's all that we have today. In our next lesson, we're going to go and figure out how to actually find these algebraically and not necessarily like just with either function notation or geometric equations. We're actually going to work them out using the antiderivatives that we talked about in the last section, which is why it's really important. If you have not watched the video from the last section, you need to make sure that you go and do that. Hope everyone enjoys, hopefully, what is our last day of virtual work.